let f of x be given as this piecewise function. We want to see if it's continuous or differentiable at x equals 0. The function is continuous at x equals 0 if the limit as x approaches 0 of f of x is equal to f of 0. So in order to take the limit, you have to look at it from the left and the right. The left side from the left side is going to be when x approaches 0 from the negative x value, so that's going to be negative x squared plus 1. The limit of that is just 1. Now from the right, we're going to be approaching it from the positive x values, which is sine x over x. We know that the limit of this is 1. And also, f of 0, we have to use the bottom function because x equals 0 is included here. So we plug that in, we get 1. So we see that because the left hand and the right hand limit are equal to 1, this limit is 1, and then f of 0 is also 1. So these two are equal, which means the function is continuous at x equals 0. Now let's take the derivative. So the derivative of sine x over x, we use the quotient rule. So you take the bottom squared first. The derivative top is cosine of x times the bottom. I'll just put that in front. Minus the derivative of the bottom is 1 times the top. So that's what we have here. The derivative of negative x squared plus 1 is negative 2x. And so if the function is differentiable at x equals 0, the limit as x approaches 0 f prime of x is equal to f prime of 0. So let's take the limit first as x approaches 0 from the left. So that's going to be this function over here. The derivative as x approaches 0 from the left, that's going to be negative 2x. Plug in 0, you get 0. And then from the right, we're going to use this derivative up here. And notice that I get 0 over 0. So I use L'Hopital's rule, take the derivative of the top, derivative of the bottom. So I use the product rule for x cosine of x, which is this part right here. And then the derivative of negative sine of x is negative cosine of x. So now the cosine of x's are going to cancel. And I'm going to have limit as x approaches 0 from the right. The negative could come out in front. Actually, the negative 1/2 could come out in front. And then we'll have sine of x over x. And then we have x also here. So it's x sine of x over x. X's are going to cancel. So it's just negative 1/2 limit x approaches 0 from the right of sine of x. And clearly that's going to be 0. Now to find the derivative at x equals 0, just plug it into the bottom function here because 0 is in this interval. Plug it in to get 0. So we see that the left hand and the right hand derivative at x equals 0 is 0, and the value at x equals 0, the derivative is also 0. And so because these two are equal, we say the function is differentiable at x equals 0.